my name is Damian Brady. I am a cloud developer advocate at Microsoft. That's my Twitter handle. A cloud developer advocate is basically a role at Microsoft where our job is to help people succeed at Azure, succeed on the cloud. My focus is DevOps, so I talk a lot about Visual Studio Team Services, but also a little more lately on things like the Kubernetes offerings and containers and the ways to deploy all of the different services and things like that. So just as much cloud as DevOps these days as well. I used to work before Microsoft at Octopus Deploy, who I think a few people know Octopus Deploy. And then before that I worked at SSW, started the Brisbane office as Adam said before. I spent a year in Toronto not long ago, so we came back to Australia this year. Last year was in Canada, where I joined Microsoft while I was there. Much easier to travel around the US in Canada. Now it's a 18-hour trip and it's a little bit more painful. But I like being back in Australia. I'm based in Newcastle. I do a lot of surfing, beach volleyball, travel, things like that. That's kind of what I like doing. So surfing and beach volleyball is much easier when there is a beach and waves. So kind of happy to be back. I also saw this, which was one of the tweets about the Melbourne.net user group, and then one of my friends said somebody needs to Photoshop Damian into something to prove that he's now apparently Mr. DevOps, so I did this. This is what I spend my time on. That's the Mr. Robot logo, just in case anybody wasn't aware. Anyway, so this is my new, new thing. I'm part of this team at Microsoft as well, the kind of jokingly named League of Extraordinary Cloud DevOps Advocates, which just rolls off the tongue. It was a joke to start off with, and then people started using it. And so now we've kind of got this hashtag LOECDA, which is a little bit like a bat signal. If you use that hashtag and send a message to Twitter with that hashtag, one of us or several of us will jump in and help answer that problem, answer that question, or connect you with somebody who can. The website also has our dates that we're traveling to various places as well, so you can see where we are at different times. We're also part of a larger group of cloud developer advocates at Microsoft. All of us focus on various things as well. So we focus on, my team focuses on DevOps. There are teams that focus on containers, teams that focus on .NET, on Linux and open source, what else? Xamarin, mobile, and AI and cognitive services and machine learning and stuff as well. So there's all these teams full of people who do all sorts of different things. That's the URL of our website where you can see who it is, who we are and what we do as well. So I'd encourage you to look at that stuff if you have problems with anything in Azure. It's a great way of getting hold of somebody who can answer the question or put you onto somebody who can. All right. So I'm going to do this in two kind of parts. This talk is really about DevOps and deploying stuff to the cloud, to Azure, and the right ways of doing it. So part one is really going to be, okay, how do we actually get started? How do we get our web app, deploy it up to Azure, and how do we do it properly? Like, what are the best practices for actually following it? Part two is going to go down a little bit further along that track, and it'll be a bit more around, well, that's great, you've done a hello world, but what about these things that a company who's writing real software needs to worry about? So that'll be after we build that first kind of pipeline. It's worth starting with DevOps itself. So DevOps is one of these kind of buzzwords now where it means a lot of different things to a lot of different people. The way that we define DevOps at Microsoft is that it's the union of people, process, and products to enable continuous delivery of value to our end users. Now there's a few different parts that I like to focus on with this one. One is the fact that it's people, process, and products. So yeah, I'd love everybody to use Visual Studio Team Services, VSTS, but if I told you that that was going to solve all of your problems, I'd be lying to you, right? You can't just put a product in place and it solves all of your people and process problems. The people themselves need to be bought into the idea of delivering continuous value to your users, and the processes need to be able to support that. You can't say that you're doing DevOps just because you have VSTS if there's a 3-month delivery cycle and it needs to be signed off by 30 people and you're only allowed to fix bugs at the end of each process and so on, right? That's not what DevOps is about. The other key thing here is that it's delivering value. So developers, and I come from a development background, we think about DevOps quite often as the deployment, like the build and deploy out to production, and then we still kind of wash our hands of it and say, well, that's all we really care about. Infrastructure people think about DevOps in a very different way. They might think about being able to reliably and quickly spin up infrastructure, make sure stuff is available, monitoring telemetry availability, and making sure that you can scale up and down really quickly, and things like that. Infrastructure as code and all that kind of stuff. The reality is DevOps is really anything that adds value. So scaling up your web servers when you have unexpected load over Christmas, for example, that is delivering value to your end users. And conversely, writing a new feature that nobody actually uses, you're not delivering value. You're delivering code, but that's not necessarily value. So it's really, really important that you measure this stuff as well. Otherwise, you're just guessing what's valuable. So this whole cycle of we've put something in production, are people using it the way that we expected them to use it, and are they actually finding it valuable, is really core to DevOps as well. If you're not measuring this stuff, then you're just guessing what's valuable, and that's kind of contrary to this whole idea. So I could talk for hours on DevOps, but I'll move on a little bit. One other way of thinking about it is this kind of cycle, this delivery cycle of planning what you're going to do based on information you've got from users and what's most important, and things that people like and things that people don't like. Developing that quickly, testing it, make sure it works, building it and releasing it out to production as quickly as possible in a reliable, maintainable way, and then looking at what happens in production as well and monitoring that and learning from it and feeding that back into your planning as well. So it's this whole cycle. The key to DevOps is doing this as fast as you can without breaking stuff. Ultimately, that's kind of what it comes down to. And this doesn't necessarily mean code, remember? This could be infrastructure as well. Your development and test could be, how do we scale up our web servers more efficiently? Or how do we add this particular value so that people aren't waiting so long? Let's release that change, let's monitor how it actually works, and let's adjust things if it's not working the way we want. So that's really what DevOps is in a nutshell. Why it's important, kind of the number one reason is that your competition's already doing it. And even if you are an internal IT department in an organization and your customers are other people in your company, they're going to be impacted by any mistakes that you make. Or they're going to be impacted by the fact that you can't fix a bug for 3 months, but your competitor or your company's competitor, they're available all the time because any bugs that come up in their organization get fixed immediately, right? So it doesn't matter what you're doing, your competition's already starting to do this stuff, and if you can't keep up, you'll start losing business to other people. DevOps allows you to increase this velocity. So fix things faster, reduce your downtime. So if stuff goes wrong, you have a process in place where you can quickly fix it and push out those changes. Downtime gets reduced. We'll talk a little bit more about downtime and what that means for web apps as well a little bit later. And it also, importantly, kind of reduces human error. Automation is a really big part of DevOps. And if you have somebody clicking around and typing things into fields and RDPing onto servers, there's a lot of opportunity for making mistakes. And people are bad at that stuff. Scripts do the same thing every time, right? Scripts and tools that you've told, this is what you're doing this time, they'll do it the same way every time, right? They're not tired or hungover or, don't care today, or just forget something, right? The Microsoft solution for DevOps is Visual Studio Team Services or Team Foundation Server. These are actually exactly the same code base. The only difference is that VSTS is updated on a 3-weekly basis. Every 3 weeks there's an update to VSTS, sometimes more often than that, depending on if they need to push out changes. And then Team Foundation Server, every 3 months, the VSTS changes get rolled up, and then that gets released as a new version of Team Foundation Server. But ultimately, it's exactly the same product. VSTS is hosted by Microsoft on Azure for you, so you don't need to worry about the infrastructure, and TFS is an on-premises installation of the application. The product itself has a ton of different stuff across that whole DevOps scenario. So everything from source control, planning, build, release, feedback, load testing, all that kind of stuff is kind of part of VSTS. That said, this is not the same Microsoft of 20 years ago. If you start using VSTS for just your source control, you don't have to use it for everything else. You could use VSTS for your source control and then use Jenkins for your builds and Octopus Deploy for your releases, and VSTS works really nicely with those products. Or you could put your code in GitHub and just use the planning side of it. All of this stuff actually integrates really, really well with other products. So this is the end-to-end solution, especially for deploying to Azure. But if you already have investments in other tools, we're not going to stop you using them. And in fact, there are teams at Microsoft dedicated to making it easy for you to use non-Microsoft products, which is kind of a weird thing. And 10 years ago, that would have been a very strange thing to say inside Microsoft. But that's the scenario now. I'm just going to have a drink. Of course, if you're deploying to Azure, VSTS is kind of your no-brainer solution. And that's really because everything's kind of sitting together, right? VSTS is hosted on Azure. If you're deploying to Azure, there's some great integration between VSTS and Azure that make it really easy to do that kind of work. So these two products work together really, really well. If you're deploying to Azure, VSTS is kind of your no-brainer solution for actually doing those deployments. Whether your code's in GitHub or a local repository or VSTS, no matter how you do your planning or builds, releasing to Azure is kind of awesome through VSTS. So, enough talking about stuff. Let's actually build a pipeline, and I'll show you how easy it is to actually get started with this stuff. So, let's see what stopped loading while I've been talking. I have an ASP.NET web application. It's in source control at the moment, so it's sitting in my repository, in my Visual Studio Team Services repository, but it could be in GitHub, it could be in a different repo. I've just kind of started this at a point where I have the code and I have the repository and the ASP.NET application. So I want to deploy it somewhere. So let's go to Azure and let's change the dashboard I'm on. And let's create a new web app to deploy it to. So let's choose web app. I'm going to enter a name, so this can be SSW Sydney. Is that going to work, or has somebody taken it? Nope. I'm going to use this subscription. I'm going to create a new resource group. And I could run it on Windows or Linux. I'm going to run it on Windows just because this is kind of the easy path. And then choosing an app service plan is important as well. An app service plan, you can kind of think of it basically as how much am I going to pay for this, right? So my standard pricing tier means that everything in this resource group is going to be at this pricing level. This is how much I'll pay for it. I'm what we like to call in our team, I'm cloud privileged, which means that I don't need to pay for any of this stuff. So I could up that if I wanted to, but I'm just going to leave it as S1. I could also turn on Application Insights, but we're not really going to get enough traffic to make that valuable. So we'll leave that off at the moment. So let's create that. So this is going away. It's basically spinning up an Azure App Service, which is going to host my web app on a Windows base. Right? You might have also seen DevOps projects. And this is a relatively new thing. It's still in preview. You can search for a DevOps project, and this is a service that's there, and create a new DevOps project. And what this is going to do is it's going to build not just the sample code for you in whatever language you choose, but it's going to build an entire CI/CD pipeline for you using VSTS and the Azure App Service that it needs to run on as well. What's really cool about this is that when you say add new, you get the choice of .NET, Java, static websites, Node, PHP, Python, or you can point at your own code as well. So if I wanted to use Node, for example, and went next, now it knows how to build an Express.js app or a sales app or basically like a simple Node app, let's say Express. And then I can choose whether to run it as web app for containers, which will run on a Linux app service running in a Docker container, or I can run it just as a web app on Windows, which will run basically with IIS backing it. If I went to, for example, .NET and said ASP.NET Core, now I get Windows, so ASP.NET Core running on Windows, on Linux, containers, or it'll even spin up a virtual machine for me. And remember, this is building the whole CI/CD pipeline for me, not just the application itself, not just the code. The code, the build steps, the release steps, and all the resources in Azure to deploy it. What you'll end up with when you finish is, here's an example of a node one, for example, that I did before. You end up with this nice view of all of that stuff and how it kind of hooks in together. So when it loads, which is fun, you'll see.
While it's loading,
yeah.
I'll fire a quick question.
Sure.
Can you add other components to it, like a SQL database and BSC directory, that kind of stuff, or is that?
So the question, you had the mic, that's fine, right? Question was, can you add more stuff to it? So if you had a database or some other services and things like that. With this wizard, no, this wizard's basically just a starting point. It'll let you choose various things, but what it creates, you have full control over. So it'll create a build definition for what you've got here, but if you wanted to add to that build definition, that's trivial to do. If you wanted to add to the release, that's trivial as well. So as an example, here's the node one. I've got the code sitting in VSTS. I've got the build definition, and then the release definition as well. You can see the repository. Application Insights is set up for me as well. Here's the app service, that application endpoint, so I can actually visit the page. I haven't done that for a little bit, so it might spin up. But if I wanted to add stuff to this build definition, I can click on the link to the build, and it'll take me to VSTS, to my build definition. If I edit that, you can see all the steps. So nothing's hidden from you. Like all of the steps that it's actually using to build, which in this case is build an image and then push the image to a registry. If I wanted to add some testing steps and things like that, new components, I have full control over what it's created. That's either loading or it's just doing something weird. So that's the DevOps project. So if you wanted to do everything in one hit, that's great. I'm going to do it using the code that I've got, and I'm going to do it a bit more of a traditional way as well. So let's go back to our dashboard. We should be able to see that that's completed. I don't know what's using all my credit. Interesting. So let's go to our resource. So this is my app service. This is my website. If I go to that URL, I'll see that I don't really get much there at all. I basically have just got a startup page with some events, which is interesting. I'll be there and there, so that's going to be fun. And so we have our web app already set up. So there's some questions about how to deploy it. So we have our stuff in Visual Studio. We could right-click on here and go to Publish. But if you've ever heard anything about me before, you may have heard me say, friends don't let friends right-click publish. I've even got stickers if people want stickers, saying friends don't let friends right-click publish. And the reason is there's so much that depends on my situation here. If I'm working with 3 or 4 other team members, who's doing the deployments? Is it me? Have I got all of their changes, or am I just deploying my stuff? Did I run all the tests? Do the tests run? Do I have something installed on my machine that's not installed on anybody else's, or not installed on the server that I'm deploying to? Like, there's so much that depends on me as a person and my computer. If this thing blows up, can we still deploy our application? Like, that's a question as well. So what we really want is a continuous integration server. So continuous integration being taking my code and everybody else's code, integrating it together and making sure that it still builds, the tests still pass, all of that sort of stuff. And then a continuous deployment or continuous delivery release where I know that it'll put it into a package that can be deployed, and it will deploy it to maybe a test site so I know that it's actually running. The advantage of doing these things in an automated way as well is that this stuff will just happen. I can just write code and not worry about that on a day-to-day basis. If I've broken the build, somebody will tell me, or the tool will tell me, hey, that change you just made broke the build. Or these tests are failing now, you can't deploy this. So I can go and do that immediately. So don't right-click publish. A slightly better way of doing it, and actually let's talk about the worst ways of doing it. So you can see there's an FTP host name here. I could FTP the files up to Azure, and it would build it for me using a tool called Kudu, which I'll talk about in a sec, and then that will start running in this app service as well. So I can FTP stuff up. I can also, using Kudu, even drag and drop files in there. and it will compile it for me and run the stuff. These are both pretty bad ways of doing stuff, right? I wouldn't recommend doing that because while you're doing it, it's building, it's deploying. If you've broken it, your site's down now. There's no opportunity to test that everything works, and there's no opportunity to, let people see it before it actually goes live. Make sure your builds work together and things like that. So one slightly better way of doing it would be to go to the deployment options section and link it to a Git repository. So basically saying, when I make a change and push those changes to my Git repository, pick up that code, compile it, and deploy it for me. So I'm going to set this up just to show you what it looks like. The source for my code could be in GitHub. It could be in Bitbucket, even Dropbox, which is not a great source control tool, by the way. Mine's in VSTS. So let's do that. We'll choose it's in Demo MS Demos. The project that I'm using is ASP.NET Full, so we'll choose that. I'm using the master branch. I have no performance tests. I could configure some performance tests before it deployed, but I'm not going to do that. So I'm going to let this set up. So what this is doing is it's setting up a synchronization basically between my Git repository and Azure, this Azure App Service. So what that means is that every time I make a change to my Git repository, every time I push to that master branch, whether it's through a pull request or just pushing directly to master, Azure will pick it up, it'll compile that stuff, and it'll deploy it out to this location. Now you can see already we've got this VSTS building process that's happening right now. The way it's doing that, I mentioned Kudu before, so let's just zoom in a bit so you can see it. Kudu is a really cool tool. It gives you a lot more than just building it and showing it to you. If you grab the bit before Azure Websites and do .scm, that's how you get to Kudu for any of your app services. And it should, in a second, give me, it's actually making me sign in, which is probably good. I mean, I'd like it to know who I am. It's going to show me this kind of a dashboard of what's happening. So you can see the build of Kudu itself, the Azure App Service version that's running. The site's been up for 49 seconds, which is good. You can even do things like run a PowerShell command line and then even see what's running on that machine, what files are on that machine and things like that. So I can do an ls and it'll show me what's in those folders, like right from inside the browser. So that's pretty cool. The other thing that is really interesting is you can look at the deployments. So there's a REST API here as well. So we can see here that there is one deployment that is ongoing. It's in progress, or progress is nothing, start time is there, complete equals true. So it's apparently finished already. Oh yep, there we go, it's already finished. So that deployment has happened. It's taken my code from source control. If I go back to that, oh, we don't want that. If I go back to that website, if I try to go back to that website, if I can use my fingers properly, it will show you the website that we've actually started. We can drill into these deployment details as well and see exactly what happened. And even with things like generating the deployment script and running that deployment command, we can see the logs of what happened when it grabbed all of those files. So the deployment script creation isn't very interesting, but the deployment log is pretty interesting. This shows all the files that it's grabbing, it shows you the compile, it shows all of the stuff that's happening. You do actually get control over this if you wanted to. There's a file you can put in your repository that will tell Kudu how to build your application, so you could add tests and things like that. But I'm going to argue that this is also not a great way of deploying your application. Once again, if I make a change to my source code that breaks something in a subtle way, this is going to run. It might deploy something broken to my production site, and I haven't got any opportunity to test that that is working again. Sometimes people will set up a branching strategy like Git flow or something like that, where they do their work in a development branch, test it there, and then merge back into master, and then master will deploy to their production site. The problem is that merge back into master, if that doesn't work 100% of the time, you're going to end up with broken stuff in production. You don't want to deploy code that's only existed in that form, just before you deploy it. So production should not contain something that you just merged. You should get the opportunity to test it, do some load tests maybe, some QA, stuff like that, before it goes out to production. So this, all right. The problem is I didn't go to the right URL, but there you go. There's our ASP.NET web app running, but that's come from a sync from my Git repository. Now, I don't want to do this, so I'm going to disconnect that. Pretty easy to disconnect it from source control, and that won't happen anymore. What I am going to do instead is set up continuous delivery. So this is another feature that's in preview, but it's pretty mature. And this will spin up a CI/CD pipeline for me to do all this work. So let's configure this, and we get a similar kind of wizard, I guess, as we did before. It wants to know where the code is. It's in VSTS, but again, it could be GitHub, an external Git repository, or a local Git repository. I'm using my Demo MS Demos VSTS, ASP.NET Full, that's the repository, and that's the branch. So this is where the code comes from. But it's not just going to grab this code and deploy it, it's going to build it properly first. So it needs to know what I'm building. Now this is an ASP.NET Full web application, but once again, you can see we can build core, Node.js, PHP, Python, or a static web app. So it knows how to build a build definition and a release definition for these languages. We're going to leave it at ASP.NET. Again, I could do some load testing. I could deploy to a different slot, but we're not up to that point yet, so let's leave that and actually set that up. So this is taking that code, it's going and talking to VSTS, and it's setting up a build definition, a continuous integration definition, which means every time somebody commits to master, it will build that application. It will actually run tests to make sure the tests all pass. And then it'll produce an artifact basically that is the application built, ready to be deployed. It also is setting up a release definition, which knows how to take that artifact that I've just built and it knows how to deploy it to Azure. And it'll set that up with a continuous deployment trigger. So a continuous integration trigger, so it'll build every time I make a change and run tests. And then a continuous deployment trigger, which means that every time there's a new version of the application, it'll deploy it to Azure, to this app service. Now, this will take a minute or two to set up. Any questions about what I've shown so far? Yeah.
When you choose HTML integration, there is some task runner in the background, like Google or other SaaS compiler.
So the question was, if you choose a static HTML site, is there a test part of that build definition? Yeah. My guess would be no, but I haven't actually created one before, so I don't know. The good thing about this is, even though it's set up the build definition for me, I have full control over what that build definition does. This is a starting point. So this is building the application, running the tests, publishing the artifacts up. If I wanted to add more stuff to that build definition, I can absolutely do that. And in fact, I probably should do that, because this is really just a basic starting point. So it gave me links there for the build definition, the release definition, and told me that a build had actually been triggered. I clicked on the link to go to the build definition, and it's doing this now. So this is showing me the build that it's created, or the build definition that it's created. This is conference Wi-Fi they always talk about, but this is a cable. So there's a build in progress right now. While that's running, I'm just going to edit this build definition just to show you what it's created for me. And you'll see pretty much exactly what I said. It's grabbing the source, it's doing a compile, it's running the tests. So it's actually, I've got a test project here. By default, it just looks for any CS proj or any project file that has tests at the end of it. So we've got our build, our test assemblies. It's looking for any assembly with tests in it, and it'll run those tests. Publishing my symbols up, and then publishing the artifact, which is the end product. So I have full control. I can add new tasks. I can add whatever I want to this. I can make changes to all of this sort of stuff. I'm going to change one thing, and I'm going to change the agent queue. So by default, this will set up a build which will run on a hosted VS 2017 build agent. So what that means is the agent that does the build for you is hosted by Microsoft. It basically gets spun up, not quite on demand, but it gets spun up for this build as a fresh new instance of a build agent. So no files left over from anybody else's build or anything like that. Spun up fresh, does your build, and then tears itself down at the end. So you don't have to worry about the infrastructure for build agents or anything like that. What I am going to do, and you can see there's a hosted VS 2017, there's a more lightweight hosted one, Linux and Mac OS as well. So you can actually build Mac and iPhone apps on hosted agents without needing a Mac yourself now, which is kind of cool. But you can also do private builds, private agents as well. So these are agents, it's just a tool that you install on your local machine. It can run basically from the command line on demand, or it can be set up to run automatically. In the case of Linux, it just runs as a background service. In Windows, I think it's the same thing, a background service. And so that'll pick it up. The reasons you might want to use your own queue, I'm using my own queue because I just threw a whole lot of hardware at the machine that's going to run these builds. It certainly makes the demos a lot faster. The other thing is it will cache all my NuGet packages. The hosted agents, because they get spun up on demand, they won't cache your NuGet packages or your NPM packages or anything, which means every time you do a build, it's going to pull down those same packages, even though it hasn't changed, because this is a fresh machine for you. The other reason you might want to use it is if you have some tools on your, that are required for your build that you need to install, you can install them ahead of time on that machine. So maybe you're using some testing tool and you need Firefox installed so you can do some headless Selenium testing or something like that. If you have your own build agent, you can install that yourself. You can do that with the hosted agents too. The agent itself, by default, I believe runs, on Linux at least, it runs as root. So you can do whatever you want as part of that install, but remember it's a fresh machine, so that means if you want to install a new tool, you're going to have to do that at the start of every single build, which is time consuming and takes a bit of effort. Yeah.
The machine you're talking about as a hosted agent, is that a machine that has to sit in the cloud, or can you register a local machine that's somehow a slave to network build process?
So the question was, is that agent something that has to live in the cloud, or can it be a local machine or anything like that? It can literally be anywhere, pretty much. As long as it can talk to VSTS, it will just work. So I actually have, let's clear this. Nope. This is not very big, is it? Can I make this bigger? No. I'll just zoom in when I get to it. So I have an agent here, and I could run that up, and it'll just run the agent, and now that's a build agent that's available to my VSTS instance. When you run that config CMD, it'll ask you for all the credentials and details and stuff to connect to VSTS, but this could run on my local machine. In my case, it's running in a VM which just happens to be in Azure, but it could be a VM locally, it could be the machine under my desk, it could be anywhere really. You can also run these agents in Docker containers. There are some walkthroughs for doing that, I think, on Donovan Brown's blog, maybe. If not, it should be relatively easy to find. Spinning up an agent on a Docker container, and you can even start them as a first step in your build process, start that up, and then your subsequent phase will run on that agent you just started up, and then at the end you can tear it back down again. Or start a VM, run the build, stop the VM, so you stop getting charged for it. So that's an option as well, yeah.
So that start-stop thing, you could do that with Azure as well, I'm supposing you're not paying for your container to be running while you're not building.
So the question was you could start it before, or the comment was you can start it before the build starts and then shut it down at the end, so you're not paying for it when it's not building? Yeah, absolutely. So the way you'd probably do that is I have one phase here. You'd probably do an agentless phase, so you don't need an agent to run this. And in that phase, you would do some PowerShell or Azure script or something like that to actually spin that up, to tell it to start that agent or start that virtual machine. And then you'd have the next the next phase would be running on an agent sorry, let me backtrack a little bit. The agentless phase doesn't need an agent at all, as you'd guess. But the agent phases, so this phase 1 that runs on an agent, I'm choosing the agent queue. So I have the hosted queue or my private queue or something like that. These are basically pools of agents. So you can have a pool that's empty or has agents that aren't running right now. When you start up that agent, it'll say, oh, there's one available for you, and it'll continue that build in that phase. So yeah, that's absolutely a pattern you can use. Once again, I'm cloud privileged, so I don't really need to worry about shutting down that VM when I'm not using it. I just keep it running. Scott Guthrie pays for it for me, which is great. So the other thing I could do is I could get my code from Git, GitHub, Enterprise, Subversion, Bitbucket, an external Git. I could get it from a whole lot of different places as well. And I could change the actual phase that it runs, the agent it runs on, the steps that I'm running and all that kind of stuff as well. All right, this build has almost certainly completed by now, and it's probably, oops, let's just save the change I made. I don't know why I'm leaving me comments for why I changed it, but there you go. So this build has succeeded, and you can see, once again, nothing's really hidden from you. What the agent ran and the logs that actually came out of that agent from the machine that was running on are available to you as well. So if you have a look at the actual build itself, you should be able to see in logs, once this loads, that everything that happened is completely available to you, as if you were watching the command line while it was running. That'll refresh live while you're watching the build as well, as you go through these steps. So that's there. Once that build's completed, we can see that it ran our tests. All 3 of them passed, which is good. Means I haven't written any real code yet. We get all of our associated changes. This was the first build, so it has all of my associated changes, so everything that was done. And if I had work items in VSTS, so tasks that that I'd linked to these commits, they'd be here as well. So we'd see all of this traceability in there as well. You can see as well, down here with the deployments, you can see there was a deployment to the production one, to the production site, which has succeeded as well. So while that's going, actually, it's going to be exactly the same website. So there's no point really showing you that. But you can see the releases that happened as well. And this release, which has been created, should have been deployed to what it's calling the production site. And that's succeeded as well. And once again, you get all of the logs. You can see everything that happened. You even get a dump of the environment variables and things that are appropriate for that deployment. So it's showing you everything. And this is set up automatically. Like, all I did was answer the questions in that setup, and I have all of this stuff. I have complete access to that release definition as well, exactly the same as the build definition. I can choose where to run it, and I can choose what artifacts it's getting. So I could add artifacts from a Git repository, a Team Foundation server, from Jenkins. I can pull artifacts from Jenkins and trigger a release based on that as well. Docker, all sorts of stuff like that as well. I'm going to get into some more of this release definition stuff when we move on to that next part. But the key things I want you to see here really are the following, right? Number one is that we're not restricting you to .NET stuff. It's not Microsoft only. You saw that there was any language deploying to any platform. Can deploy to Docker on Linux. We can build for Mac OS or for iOS and deploy to some cloud service that is running pretend iPhones and then out to the App Store, for example. All of this stuff is supported from VSTS, so we're not locking you into the Microsoft ecosystem at all. So any language, any platform. The other key point is that there's this kind of scale of good ways of deploying your application all the way through to bad ways of deploying your application. So the bad stuff is right-click publish, obviously, copying and pasting your stuff into production, RDPing onto servers, manually pushing to a remote Git repository. So that's one of the other options I didn't mention as well. You can actually say, hey, here's a push to a Git repository, an upstream Git repository, and that Git repository represents that Azure web app. So rather than going through your source control, you just go straight to Azure, and then Kudu kicks in and it builds it and deploys it as well. Or FTP or something. But in all of these cases, you're kind of going from your local machine, pushing those files up to Azure, and if something goes wrong, or if you're deploying stuff that is not actually valuable, then the user is going to suffer at the end of this as well. Production will go down, it's not going to work properly, all that kind of stuff. There's kind of a middle ground. A lot of people like this sync from Git stuff. So this was the deployment options bit that I had before, where I linked it to that repository. This is a little bit better in that you still kind of get a continuous integration. Every time there's a master branch change, there'll be a new build and it'll deploy to that location, but you still don't get any opportunity to test it before it goes to production. If you do want to test before it goes to production, then you can set up a sync in a different branch, and then your release branch maybe goes to production, but then you've got merge conflicts that could fail just before you're deploying to production. So it's better, but it's not really great. The ideal way to do it really is this CI/CD pipeline all the way to Azure with VSTS, where you have full control over the build and the testing and all that sort of stuff, and then full control over that release process, how it actually gets released. We'll add new environments and stuff soon. So you can release the test environments first before it actually goes out to production. So that's kind of the good way of doing it. So that's setting up the basic pipeline, which is kind of where I'm at for part one, right? And I know that what you've seen is basically a hello world, right? Hello world, set up a basic pipeline, it'll do a build, it'll run the tests, it'll deploy it to Azure, but in the real world, there's a lot more challenges that come up. So these are things like approvals. You probably don't want all of your code to go directly out to production if it works. Maybe you want some kind of code review process or an approval before you go from test to QA, and maybe from QA to production, right? You probably want some more process around that. You also probably don't want downtime. So when I was doing that deployment, while it's doing the deployment, the website's pretty much unavailable. And it might only take a few seconds, but you don't want that downtime on your production environment. There's also the idea of infrastructure. So I went and set up that web app, but if I want to deploy this out to a new set of resources, or if I want to scale up that website or something like that, I want that to be part of my release definition, part of my pipeline as well. I don't want to be just deploying code to something that I think exists, right? Or that I am relying on existing. I want to be able to rebuild this if it breaks, scale it up if I need to, patch it if I need to do that as well. And then finally, we haven't really closed this loop of monitoring what's happening in production as well. So part two of this talk is really going to be addressing each of these challenges, sometimes at a pretty high level, like just introducing ways to fix it, but we're going to look at that in part two, which is the real world in which we stop pretending hello world is real, right? Is a real scenario. So before we move on to part two, any questions about what's happening so far? Mm-hmm?
You've sat there in your demo bit for Azure Web Apps, whatever they call it today.
Yeah.
The pipeline technology looks great, looks fantastic, but does that leverage into Azure Functions and all of the additional components that you can link repos to?
It definitely does. Let me show you something really, really quickly then. And this is the deployment process. This is an app type of web app, and that drop-down has a Linux web app, functions, API, and mobile apps. So this is just in the app service one. If I wanted to deploy something else, what's an example? What's something logic? Oh, you're going to test me. Oh, okay, there's that one.
Database security changes.
Yeah, so database, there's definitely an answer in that. Virtual machines as well. So just to repeat the question as well, sorry, I forgot to do that. But the question was, I've shown the web app stuff, but what about other things that Azure offers? Logic apps, VMs, database stuff. So Azure SQL database deployments with DAC packs. MySQL, I haven't actually seen this one. This is new since I last looked at this product. And then there's stuff from the marketplace as well. So enables TDE on all Azure databases. I don't know what that means. Trusted device encryption. Oh, that's pretty cool. So yeah, device encryption on the Azure databases, which is cool. Octopus deploy integration. That's a great extension written by somebody really cool. I wrote that one. Redgate Ready Roll as well, if you want to do database migrations using Redgate stuff, DLM automation. So this is just searching for database, right? All of this came from the marketplace. So the marketplace is basically a way that you can find, it's weird that, so there used to actually be a link to the marketplace. If you go to marketplace.visualstudio.com, you can see all of these ones. So Visual Studio Team Services, and how many are there now? Let's look for the build and release ones, just to see how many there are. So there's 440 extensions that you can install in VSTS or TFS in most cases, and that adds like probably well over 600 or 700 new tasks that you can have as part of your deployment. So if I searched for Azure, for example, here, and I could do this through VSTS as well, apparently that's a relatively new feature, but inline PowerShell release annotations for Application Insights is kind of useful. You can say, I just did a release, and then Application Insights knows, okay, you released version X. If stuff jumps up, that's the cause. Like if performance degrades, that was the cause. Dev Test Labs, what else have we got? I wonder if there's something in here for like cognitive services. Twitter sentiment analysis, which is, I'll explain this, so I'll come back to this a little bit later, but this is a really cool gate where you can basically say, deploy to production only if the Twitter sentiment analysis, so only if people are tweeting good things about what I just did. That's legitimately the purpose of this, and it will happen automatically as part of your deployment process. It's such cool stuff, and it uses Azure Cognitive Services for the Twitter analysis, sentiment analysis. Yeah, really cool stuff.
Build your own link in the top right.
Yeah, so there's two ways that you could do your own stuff. You could either write scripts to do it yourself, so just write PowerShell or Bash or command line stuff or whatever you wanted, or you can build your own extension. And these are relatively easy. Basically, all the extension requires is a JSON manifest file to say this is what it's called, this is where it hooks into VSTS, and so on. And then any files or any scripts and things like that that you want to run as part of your deployment. The way the Octopus deploy integration one is set up is it adds a bunch of tasks to your release and build options. So there's marketplace tasks, and then it packages up octo.exe. So when you actually run those tasks, the agent will pull down octo.exe and then just run the command line saying, package this stuff, push it to Octopus, for example. So you can put anything you want in these extensions, and it will just get used by the build or release process that you've got. These ones, you can build them yourself and make them available across your VSTS instance or TFS instance. And if you wanted to make it public, you can publish this to the marketplace as well and make it available for everyone. I think the process for doing that is still a little bit ad hoc, in that Microsoft needs to say, okay, you're a trusted publisher now, you can publish your extension. But as you've seen, there's 440 extensions. Clearly people are getting through that process pretty well. Yeah.
Is there a way, either natively or with an extension, that you can have it reject a commit if something fails, like your style rules or something like that, or tests? Like, can you get into a pipeline on a pre-commit hook or something instead of once it's happened?
So yeah, so the question was, can you get in, like, can you write an extension that'll do like a pre-commit hook or something to reject a commit if it hasn't met standards?
Well, more specifically, can you have build tasks start off a pre-commit hook rather than once the commit's completed?
Can you get build tasks to run like pre-commit?
Yes.
Pretty much. I'll show you stuff in a minute about when we talk about the approvals stuff. That basically does that exact thing. So it solves the problem, I think, that you're talking about. If I get to the end of that and you say, no, that's not right, stop me again, and I'll, yeah.
So just to clarify, probably help later. The problem is there's something wrong with the code to the point that we don't want it to be committed.
Yes.
Right.
Yeah. So yeah, the fact if there's something wrong with the code, we don't want it to be committed. Stop that from happening. And the answer is yes. That'll be in the approval stuff. There is definitely a way of doing that. Yeah. Adam, did you have a question?
I just wanted to know, do you know how many people that are using that that automatic retweeting in reality?
So yeah, do I know if many people are using that automatic Twitter analysis gate in reality? No, and my guess would actually be very few people are. I believe that extension was more or less written just to demonstrate what could be done with gates. Gates are still in preview and enabled via a feature flag in VSTS. I don't know of anybody who's using them in anger, but I mean, they might. Let's have a look at, because there are stats on who's downloaded that thing. Let's look for sentiment analysis to find that. So this extension's been installed 33 times. So my guess is not a lot of companies are actually using this as part of their pipeline. Yeah, it requires a bit of a change to the way you're releasing stuff too. Basically, you would need some kind of canary deployment out to production, or a feature flag enabled, feature, and then looking for Twitter sentiment analysis on the on that feature. But that feature has to be in production for you to get any tweets about it anyway.
Yeah.
So maybe a canary deployment and then rolling out to everybody else if the sentiment is good, for example.
So like Windows Insider.
Yeah, so like a Windows Insider build, for example, yeah. Yeah, something like that. Yep. All right, cool. Let's move on to part 2, shall we? So in part 2, we're going to take that deployment, that CI/CD build that we created to deploy our ASP.NET website, and we're going to talk about some of these challenges. So the challenge of some kind of approval process. In other words, not everything that I write goes all the way through that pipeline and out to production, which is what happens right now. We want some kind of checking in place to make sure that it's only good stuff that gets to production. So the pipeline, I like to say that a pipeline, your CI/CD pipeline, should do 2 things. One is it should automate all of that stuff, so if it's good, it gets out to production. The second thing it should do is prevent the bad stuff from getting to production, right? And people still like to have a hand in that process. There still needs to be some kind of approval to say, yeah, this looks good. Whether it's somebody doing a code review or somebody saying, look, the QA team's had a look at this and it's fine, or even automated stuff like we've run this whole suite of tests across it and it's fine, it's ready to go to production. But some kind of approval process before it actually goes all the way out. So that's the kind of first challenge in a real world scenario. I'm going to talk a little bit about reducing downtime as well. There's some pretty cool features in the web apps, in App Service, that allow you to basically get rid of downtime with some caveats. So we'll talk about that. I'm going to touch on infrastructure as well. So deploying your infrastructure alongside your application, or at least making sure that your infrastructure is in the state that it needs to be. And if you need to do upgrades or make changes to it, that can be just deployed out with everything else as well. And then finally, we're going to touch on monitoring as well. So seeing what people are actually doing in production and how you feed that back into the planning for the subsequent phases as well. So this is basically all going to be demos. There's no point in having slides talking about what I just said. So let's get into approvals. So I'm going to talk about approvals in 2 different spots. The first one is more or less exactly what you were saying with the pre-commit approvals, to make sure that, if code is not up to scratch, we don't want it to be we don't want it to be committed, basically. We don't want it to be part of our product. So the way we can do that is using what's known as branch policies in VSTS. So what branch policies allow you to do is to say, in the first case, nobody's allowed to commit to master directly. We can't let people just push their code directly to our master branch. That's our source of truth. That's the code that we want to be able to deploy. So rather, we would go through a pull request process. So this is what Microsoft does on a day-to-day basis. They have usually about in the tens of pull requests on a daily basis, and every one of those pull requests gets tested really, really thoroughly before it's allowed to be merged back into master. I'm going to set up this branch policy for my master branch right now, just to show you how this works. And so there's a number of things that I can say. Look, the policy for merging into this branch are the following things. So any kind of required policy in this basically means you can't commit directly to this branch. So I require a number of reviewers before this code can ever get merged into master. So I'm going to set that as 1, and I'm also going to check that checkbox that you should never check, which says allow users to approve their own changes. That's a stupid idea, but because I'm the only person in this repository, it's going to be a very short demo if I'm not allowed to approve my own changes. You can also say, you know, if people are waiting or reject it, you can still merge that. Again, not a great idea. And then you can reset any code review notes if it's changed since the original pull request. So if somebody's making additions to the branch that has that pull request back in, you can reset the comments and make people do them again. You can also say you want to check for linked work items. Now this is a good thing to do as well. It means that nobody can actually submit code that goes back into master without some kind of traceability into the task that they're completing. So you can't just commit code without some tracking of, well, this is the work that I'm doing, this is what it's related to. I'm not really doing work items in this demo, so I'm going to leave that one blank. I'm going to enable this one though, check for comment resolution. Oh yeah, sorry.
Quick question on that.
Yep.
Presumably they're only work items that are managed through VSTS.
Correct, yeah. So you're saying...
Not external services like Jira or something like that.
Yeah, so you were saying I'm making sure that they have to be work items that are in VSTS, and yes, for this one, absolutely, it definitely needs to be. The same thing with the source control as well. If your code's in GitHub, none of this is going to work because the branches are over there. So GitHub, I believe, has their own kind of policies as well. Like you can do essentially the same thing inside GitHub. I don't know how extensive their branch policy stuff is, but they've been around for a while doing Git for much longer than we have. So there's probably some pretty good branching policies in GitHub as well. But yeah, this is all in VSTS. So those work items have to be in VSTS. The other one, yeah, check for comment resolution basically means if somebody is reviewing it, and I've said you need at least one reviewer, and they leave a comment, the person who submitted that pull request or somebody has to mark that comment as resolved to say, yes, I understand what you've said, I fixed this thing, or yes, this is not a problem because whatever. So it has to actively be responded to. So I'm going to make that one enabled. You can enforce a merge strategy if you want to say you can't fast forward merge or you're going to squash merge all of them. So if there's 25 commits, just squash them into one commit when you merge back into master, which can be handy in some cases, it's preference. This one's really cool though, and I'm not going to enable it because it takes a little bit longer, but this is a build validation. So what you can add is a build policy to say, before I can merge this change back into master, any pull request back into master, it has to pass this build. And I've chosen the only build that I've got, but you could set up a PR build, like a completely separate build that does, maybe you want it to do more stuff, like do static code analysis, do style things to make sure that the code is up to scratch, run a whole bunch of tests, deploy it out somewhere and run some UI testing and performance testing on it, things like that. So basically your pull request has to pass this build before you can merge it back into master. So this can be really, really powerful, and Microsoft uses this internally a lot. The VSTS team has pull request builds that run, I think the last time I looked it was something like 72,000 unit tests as the pull request build, and it runs them in about 14 minutes. So they use this really extensively, right? Everything that gets changed in VSTS goes through this pull request process, and every single time there's a pull request, 70-something thousand tests are run against that change. And if it fails, you can't merge it back into master. So this is builds inside VSTS, build definitions. You can also, though, add these status policies, so third-party services. If you have some other code review product that you're using, you can set up a thing which will require approval from that third-party service. So let's say you're using some external tool that does like security checking against the code that's been written. You could have that tool grab the pull request changes, because this is just a Git branch, grab those changes, run its analysis over those changes and make sure that it actually is up to scratch. And when it is, it can notify VSTS and say, this pull request is okay to go. So you're pretty much unlimited with what you can do at this point. You can use any kind of third-party tool to say this pull request is fine. And you can also say these people need to be code reviewers every time as well. So there's a lot of stuff you can do to make sure that the code is up to scratch before it actually gets merged back into master. Does that kind of solve those issues to some extent?
Yeah, I think you've scrolled it down now.
Build
validation, I think, would be the go.
Yeah. So the build validation kind of solves that problem for making sure the code is actually good enough before it gets back into that master branch. Yep. Right, so let's save those changes. And what this will mean now is that I can't commit directly into master, and I've got to meet these two requirements before I can merge back into master. So we'll come back to that next time I do a release. The other thing I want to do is change the approvals process for my release itself. So at the moment, I'm doing a continuous deployment. So every time there's a change, I'm doing a build. And then every time there's a new artifact from my build, every time there's a new version of my application, I'm deploying straight to production. Probably not the best idea in a real environment. So all I'm going to do is change this to dev. And I'm going to duplicate this environment. So dev, now it'll deploy to my dev environment. And now I'm going to call this one production. Now you can set up these environments however you want, right? So what's happening now is it'll do my dev deployment, it'll go to production. I would obviously change this app service so it deploys to a different location or a different slot. We'll get to slots in a second, but basically a different deployment. So I'm deploying to my dev site, and then when that's okay, deploying to production. Now by default, this will automatically deploy. I don't want that. I want to make sure that it's approved before I go to production. So I can set pre-deployment conditions and I can set post-deployment conditions. So let's set up a pre-deployment condition for this production environment, and I'll set up the most basic one here. I can either do this on a schedule, I can do it based on new artifacts that have been created in a particular format. I can do it manual only. I can also do it in parallel to dev as well. So if I did after release, you can see that that picture changes. It'll just do it'll do that deployment in parallel. Can be really useful for load testing alongside deploying it to a dev environment or something like that. So I'm going to do it after the environment, and I'm going to say that this pre-deployment approvals, it needs an improver, which in my case is just going to be me because I'm the only person there. And I'm also going to uncheck this thing that you should never uncheck, which is that the person requesting the release should not approve. I'm always going to be requesting the release and I want to be able to approve it, but really you'd probably want somebody else to do it. Now I've chosen a person there, but you could also choose a group. So your QA team, for example, might approve that change to production. The other thing is the reason you have a pre and post deployment approval process is that can be really handy, especially for QA environments. You can have a pre-deployment approval where your QA team says, we are ready for the next release. We're ready for the next thing to test. So they must approve that before it goes to QA. But then they also have control over saying, this is good and it's allowed to go to the next environment. And then maybe some upper management does the pre-deployment to approval to production. But QA is still in control of saying, okay, this post-deployment stage, yes, it's actually been tested and it's ready to go to the next phase. So you'll get the same behavior basically with pre and post deployment approvals. One of the newer things that you can do as well is gates. So this is where that extension, the Twitter sentiment analysis, could be used. If I had that extension installed, when I click add for a gate, it would have another option here to say Twitter sentiment analysis. And what this basically means is that it'll delay 15 minutes from the previous environment, and then it'll check this stuff, whatever I put in here. So it'll invoke an Azure function, and then if that function returns success, it'll say, okay, good, we're good to go to the next environment. Or it'll look at monitor alerts and make sure that I haven't dramatically reduced performance of this application, for example. I don't have any new Azure alerts. Or that there's no new work items, like no new bugs that have been raised from the QA environment. And if there are, it won't let me go to production. If there are none, then it'll automatically deploy it to that next stage. So this can be really powerful for making sure there's some kind of check before you go to production, but also just doing it automatically if everything's okay. These obviously take a little bit of time to run and they're a little bit more complicated, so I'm going to leave that out for the moment and just leave this as I need to approve it. So let's save that. So what will happen now is if I actually made a change, the first thing that would happen is I can't commit to master. I have to do that through a pull request. I have to meet those branch policies before it can be merged back into master. And then when it gets merged into master, my build will kick off, and then my deployment will kick off to my dev environment. And then it's going to wait for me to approve the deployment to production. And if I do, it'll deploy automatically to production. So we kind of have this approvals process in place now. So I'm not going to run this to start off with because this actually works quite well with the next bit, which is reducing downtime. What will happen right now is when I deploy to dev, while it's doing that deployment, dev's down. When I deploy to production, while it's doing that deployment, production's unavailable. And I don't really want that. So Azure App Service has this really cool feature called deployment slots. So this basically lets me set up a new slot to say, let's say this is staging. We're just going to say OK. And what it's creating for me is basically a brand new website. So if we zoom in, staging, we can see SSW Sydney staging.azure websites, and we've got a brand new instance basically of my website up and running. So what this allows me to do is deploy my website to a staging environment and then make sure that that's working okay. And then when I'm ready to push this to production, I can hit swap, or I can do this automatically in my deployment process. And that will do basically a DNS style swap where everything that used to hit the production site will now just go and hit the staging site. So there's no downtime here. It's just at some point it'll roll over and hit the new site. You can have multiple slots in here as well. One thing that's worth mentioning with slots as well is these all live in that same app service plan. So if you have this much capacity, you're paying for this much performance, this much capacity, and you have a load testing slot, hypothetically, and you hammer that load testing slot, and then production is losing performance because all of it's being pushed to this load testing slot. You're basically sharing this capacity. So if you're doing load testing, do it on a completely different Azure App Service and use these slots primarily for deploying to and then swapping to reduce downtime. Unless you're doing some smoke testing stuff, that's probably okay, yeah.
Just a very simple question. With the deployment slots, they come under the cost of whatever the upper level web app is, presumably.
Yeah, so question about those deployment slots come under the cost of whatever the upper level Azure slot. Yeah, they do. So if I was to scale this out, for example, scale up and say I want 12 instances of this thing, that staging slot will only ever use one instance. So it'll only ever be its own one instance. The other, there's going to be 12 used for production, for example. But I'm still paying for this all underneath this same billing thing. So that the app, the pricing tier or the app service plan, that contains everything that's in this
so if I have my
web app.
original and I have a slot, I'm still paying the one plan price.
Yeah, correct. So if you have the original one and if you have your production one and your slot, you're still paying that one plan thing, I believe. Yep. Right. So we have these slots. Let's change this release definition to actually take into account those slots. Oops, that one's old. Let's look at one of the ones that's not so old. There we go. So my dev environment now, I need to change this task to deploy to a slot with this handy checkbox. And I'm going to choose the staging slot that I just created, and now it'll deploy to that staging slot, not straight to production. I'm going to add one more step, and this one came from the marketplace. and that says smoke test. So basically all this is going to do is it's going to hit a URL and make sure that I get a 200 OK, like a correct response. Now the reason I do this is not just to test that the website's working, it's also because this is an ASP.NET full framework one and it needs to spin up the first time. So I don't want to move to my production environment until, I don't want to swap them until this is actually up and running. Otherwise I'm no better off. I still have downtime while it's spinning up the first time. I need to give it a URL. Handily, I can go into the deployment and scroll down to the bottom and there's an output section. And I can say, I can give this a name like web URL, for example. Let's copy that. And then I can use that as a variable later on. So now I'm using that web URL, so the output of where it deployed to here. Now the reason I'd want to do that is if I change some stuff. Maybe I'm changing where this deploys to. There's 35 different steps in here. I have a whole bunch of stuff that uses this URL. Rather than having to go in and make sure I've changed it correctly every time, I can just use the output from that one and subsequently just use it here. So that's the staging slot or my dev environment. Let's change our production environment. I no longer need to deploy this because it's already been deployed. So let's remove that task and let's add a new task. If I search for swap, it comes up, but it's basically an Azure App Service management command. So let's add that. And I need to give it some information. I need to give it the subscription I'm using, which was set up for me. This service endpoint was set up for me from Azure when I set everything up, that communication. But I also get my subscriptions as well. So you can see that I could use those subscriptions and authorize that way. It handily gives me the scope. So this scope of this service endpoint is limited to this website. So yes, I can deploy to this slot of the website because it's still part of that website. But if I wanted to deploy to a different location, then this service endpoint, this service account is not going to be able to do that for me. So I'd need to change that later. The app service is the same. It just needs to load these. So that's SSW SID. The resource group is the same. Just spinning up. And the source slot, so where that slot, where I'm swapping from is staging, and I'm going to swap with production. So that's all I need to do for that production phase.
When you've swapped it, does it then become staging? The other one becomes the staging?
Yeah, so the question is when you swap it, does the other one become the staging? And the answer is yes, it does. It's literally just pointing the DNS or swapping the DNS over like that, which can be a little bit confusing sometimes. If you have production, so in this scenario, if I go to this SSW Sydney staging, when I do this swap, it'll deploy my new version to here, and then it'll swap them over so that the old production will now be in staging. So if you have dramatic changes, you might look at staging after their deployment to production and go, whoa, what happened? Like that's the old code, why is that still there? Sometimes people will backfill, so they'll do the swap, and then they'll deploy again to the existing staging site just to do it again so that they're not confused. I've also seen people completely wipe that staging slot when they do it. So they do the swap, production works, they make sure it works, and then they wipe staging completely. So now you're not confused, but there's also nothing in the staging slot. The other advantage of slots, though, is that if something breaks, you can swap it back quite easily. So wiping that staging slot after deploying to production doesn't give you a way back anymore. So you can try something out and you can swap it back. You can actually go even further than that if you wanted to, and there's a feature down here called testing in production. So if I had two versions of the application, one in my, let's say I created a slot called Canary, for example, and I deployed to my Canary slot. Let's pretend this is Canary. I can say I want 10% of my traffic to go to that slot. So 10% of the traffic that hits my URL will get redirected to that one, and I can make sure that everything's okay, and I can slowly increase this, or I can just say, all right, no, 100% of it now goes to that slot, or just swap them, or something like that.
So what if you got a web app and it's the DNS changes on it behind the scenes?
Mm-hmm.
How do you
Oh yeah.
keep that as an app sync?
So the question is if you have that staging slot and you do the DNS swap behind the scenes, but you have this traffic management stuff happening already, there's probably going to be a little blip where it's going to not be ideal. You can hit both of these things with an API. So you can say, right, change the traffic so that all of it goes to production and now swap the slots. And there might be a tiny increment of time where somebody who was looking at the new stuff now gets the old stuff and now gets the new stuff because they're onto production. So if I set this to 100%, that's effectively the same as just redirecting all the traffic to what I'm calling staging. If I swapped it, then all of that traffic would still be going to staging. It's just that staging has been swapped out now. So this is basically routing to whatever you're calling, like whatever slot you're calling it. So all of it to the staging slot. If I swap those over, it'll still be looking at the staging slot, but that'll be what production was. It's kind of confusing. Did I make that less confusing or more confusing? I feel like it was the latter.
Whatever's live will swap with it. Is that kind of what you're saying?
Say that again, sorry?
Whatever's live, like a client somewhere,
Yes.
it's going to swap with it to the staging.
Yeah, so whatever's live will get swapped. So basically the static routing means that something sits in between and says, well, 10% goes to what I'm calling staging, 90% goes to what I'm calling production. If you do a swap of those two slots, the same thing happens. 10% will go to what I'm calling staging and 90% will go to what I'm calling production. But these are different now, like they've swapped over. So you'd usually use one or the other at a time, I suspect. Yeah.
When you flip them, if you've got a session-aware website, does it handle the tokens?
That's kind of what I'm asking.
Yeah, so the question which I'm going to preempt, I'm going to already say I don't know the answer to. If you have a session-aware website and you swap those slots, or you not swap the slots, but you change that load, is it going to maintain that? I don't know. I don't actually know how this works. My guess would be I wouldn't rely on it doing that.
Yeah.
I don't know how it decides, but it's probably completely non-context aware, and it just, here's a request, oh, I'm going to push it over here. Here's another request, I'm going to push it over here.
Yeah.
So it probably doesn't know about that context at all. If you wanted to do that stuff, I'd probably put a load balancer that's a bit smarter in front. Yeah. Yeah. All right. Let's not save that because I don't want all of it to go to staging and confuse me. All right. So let's put these two things in practice. I changed that. Let me just make sure I did save that. Yep. Good. So the whole process now should work with my approvals and with that no downtime thing. So let's do this and let's see how it works. So number one, I am in the master branch. You can see down here. So this is the master branch and I shouldn't be able to commit a change to here. Let's do ASP.NET at SSW. Make a change, go to Team Explorer, go to Changes, say change title, do what any good developer does and not even do anything apart from saving that file. I'm just going to commit and push. Don't need to run any tests, don't need to do any of that stuff. And so it's committed that, and now it's trying to push that to the master branch. And I get a failure. Failed to push the remote repository. See the output window for more details. I'll zoom in just in case you can't see that. And so let's go to the output window and see what it said. Pushes to this branch are not permitted. You must use a pull request. So it's stopping me from doing it. And this is just Git. This isn't Visual Studio. This would happen whether you use the command line Git or any other IDE. This is just a Git thing. It's saying, sorry, I'm not going to let you do it. So let's do this on another branch. Let's create a new branch. And I'm going to call it DA Brady / this is just habit for me, by the way, my name / new title. And we're going to check that out. So let's create that branch. Now that commit that I've done is going to be on this new branch, and I need to push that branch. So you can see as well probably why I did that format, DA Brady and then the branch name. It actually puts it in a folder for me, which means it's kind of easy to navigate. So I'm going to push this up to my Git repository, and that'll go into that branch rather than against master, which is kind of step number one for doing the pull request. All right, let's jump back to our code, and we will go to code, branches, And we should be able to see there's a new branch that I've just created. There's my new title branch. I'm one commit ahead. So let's create a new pull request right from here. I could also do that in pull requests. It'd say, very similar to GitHub if you've done it there before, it says, hey, you just created a new branch. Do you want to create a pull request? So let's create a new pull request. I'll leave this title as is when it comes up, which is just change title, very descriptive. I can link work items directly if I wanted to as well, and I can see all the commits and the changes that were made. Let's create that pull request, and now we'll see the first of our approval process thing happening here. We can see these branch policies. So far, there are no comments, so they've all been resolved, but we haven't had any code reviewers review it yet. So I can't merge this back into master. I can't actually physically put this code in until I've met these branch policies. Let's just demonstrate that if somebody leaves a comment saying this is not good, now neither of those branch policies are there because I have to resolve that. I have to mark this as I've seen your comment and it's fine. So let's reply and resolve, and then once again the comment's been resolved. If I approve this, both the policies would go green and I'm then able to complete this pull request. But I could also, if I'm the person doing the pull request, I could set this up for autocomplete. So as soon as all the branch policies are met, just automatically complete it. Delete the branch after I've merged it because I don't need that branch anymore. I could even squash the changes if I wanted to. So let's set autocomplete. And now when this final policy is met, in other words, somebody has approved this change, you can see the policies have been met and that completed pull request has happened. That branch is going to be gone now because it automatically deleted it for me. And if I'm using some branching strategy like Git flow or something like that, I could cherry pick this pull request or this branch change back into another branch or something like that. I can revert the change. I can do a whole bunch of stuff there as well. The really cool thing about this is now that we've merged back into master, this has kicked off a build. So that build should have already started because now we have a change to our master branch. It's in progress. So now that we've made that change, it's actually going ahead. Now this should be a little bit faster, and you can see it's already gone past the NuGet restore step because I've cached those on my own build agent. Building should be a little bit faster. It'll run the tests, everything should work okay, and then it'll end up with an artifact which will go to my release. And then my release will deploy to my staging slot and then wait for me to approve the change to production. So let's just refresh. This is the staging slot at the moment, and this is, let's do another one. And this is my production slot. So right now, on production, I have ASP.NET. On staging, I have a blank website right now. The build's completed. If I go here, I should be able to see that it's kicked off a deployment. Oh, I would need to refresh. Let's just go to releases. And it's kicked off a release, so it should have. Will in a second, hopefully. Oh, that's interesting. Let me just refresh this stuff. Did I change anything with that artifact? Hope not. Deployments. All right, let me just quickly make sure that I haven't broken this when I played with the artifacts. Edit that release definition. There's always something. So drop, continuous deployment trigger. All right, so that should have worked. Let me just see what else it could be. If I look for my artifacts, there is a drop folder, and it does have stuff in it. Okay. As you can tell, this isn't exactly what I was expecting to happen. Oh, there we go. It just took a little while to spin that thing up. I'm too fast for it. So it's kicked off a release as a result. I didn't actually trigger that, it just took a little bit. So this release now is going out to my staging site. And once again, we can see everything that's happening. It's in progress. If I look at the logs, you can see it's doing all this stuff. It's deploying my Azure App Service. It's going to do that, and then it's going to run my smoke test, and then I should have my production site up and running. Sorry, my dev site up and running, and then it will wait for me to actually hit production. So let's just refresh that a few times. And while I'm doing that, any questions about what I've shown so far? These approval steps or the downtime stuff? Nope.
The smoke test was, that was just on your root site, correct? But presumably you can make it in link off there.
Yeah, the smoke test, the comment was the smoke test is just on my root site, but I could make that test anything, basically. So this is basically just a simple test that'll hit a URL and then make sure I get a 200 OK back within a reasonable amount of time. The value I gave it for URL was, the value I gave it for the URL was just the website that I just deployed, but I could do /API/availability or something like that. So yeah, the deployment at the moment is going to Azure. I think I just got a hint as well that it can also go to AWS. Yeah, so question about whether it can go to AWS. And the answer is yes. Let me just show you. So basically anything you can script you can do, but here's a pretty cool thing. There's an extension which was written by Amazon Web Services for VSTS that will add native steps that you can use in your build and release process. Tasks for S3, Elastic Beanstalk, AWS code deploy. So you could just use VSTS to trigger a deployment of your stuff to AWS. Lambda, CloudFormation, all sorts of stuff like that. So what's really interesting, and this is very much a non-Microsoft from 10 years ago thing, Microsoft actually worked quite closely with AWS to make sure that they could build this thing, right? They helped them through any tricky parts, they made it available, they obviously approved AWS itself as an approved marketplace producer as well, and basically made sure that it's as easy as it can be to deploy your stuff to AWS instead. So as an example, you set up an endpoint, and that's added by the AWS stuff to say, here's how I'm connecting to AWS. And then there's a whole bunch of tasks you can use, like deploying .NET Core or some other function to AWS Lambda. So it gives you all of these details. You can choose your connection to AWS, and all of this stuff will just run as part of your release definition or build definition too. So if you're deploying to AWS, I would strongly recommend installing that extension in VSTS. It just makes this stuff way easier. Failing that, you could always just write a script, PowerShell, Bash, something like that, and it would do whatever you needed to do. But this makes it much, much easier. The communication between the two of them securely is set up as part of it as well. So you don't have to keep giving it tokens or accounts or anything like that. You set that up once and then use that subsequently. Yep. All right, so where are we? With our release, we can see that it's gone to dev. So if we refresh our dev environment or our staging environment, we can see that change has made it. But production is the same as it was. That hasn't changed yet. Our release is waiting for me to approve that deployment to production. So let's do that. All good, approve. And now, down here we can see that this will basically go ahead and do that swap. Instead of actually deploying anything, remember we deployed to a slot before, all it's going to do is hit Azure and just say, swap those slots over for me. But the really cool thing is if I go to my website, this is the production one, and I just start navigating around, at some point, this will just flick over and start using my new code because it's now deployed the website. So it's already deployed the website, it's just going to swap those accounts around, or swap those DNS sites around. You'd think I'd be able to click buttons and talk at the same time, wouldn't you? But apparently I can't. So let's see how this goes. There we go. And that last click, now we're resolving to what was the staging site. If we go back to staging, we can see that swap has completed as well, and we're back to what the old production was. The important thing to note there is that I didn't get any downtime while I was clicking around. that was just a straight swap, and at some point it just now resolves to the new site. So people using the site, provided there are two versions that are compatible and you can actually have both of them running at the same time against the same backend, which is a bit problematic, but if your database changes, you're going to make sure that change is capable of working with both versions. Whole different talk on that. But as long as these things can run in parallel, there's no downtime at all. You don't need to worry about it. It will just flick across. So that's downtime. The next thing I was going to talk about was infrastructure. So I'm also conscious of time because I need to get to the airport. So let's just touch on this really quickly. So one of the things you can do with your deployment is actually make sure the infrastructure is working as well. Now, I found it hard when I started to actually work out how to get the templates and get this stuff set up for the first time. So I found that the easiest way to do this is SSW Sydney. Let's just go to the app service again. Oh, there we go. And let's go to this resource group. So the way you want to do this is basically say, here's the resource group, all of the resources in Azure that I need, whether they be the app service itself, a Cosmos DB database, networking stuff, a VM here, all that kind of stuff. And you want to put that in a template and then tell your release definition, here's what the environment I'm deploying to should look like. And there's a few options that you get when you say this is what it should look like as well. But how do you get that template? Probably the easiest way to do it is in your resource group, which is the group in Azure that has all of the different resources that you're using as part of this application. You can go to automation script. So you can see here are the resources. There's the app service plan, how much I'm paying. There is my app service, and then there's my staging site as well. These are the resources I'm using right now. If I go to the automation script tab, it will give me the template and then the parameters for that template. I'm just going to zoom out a tiny bit. It'll give me the template and then the parameters for the template, so the variables that I need to pass it to set this up the way it is. It'll also give me a script that I can run using the Azure CLI to actually deploy this stuff out if I want, or PowerShell or .NET or Ruby for some reason, which is interesting. There you go. So what I can do is if I want this infrastructure to be part of my deployment, I can grab this template, the JSON, and add it to my project. And then I can add the parameters, which are basically the variables, which is the site name, the server farm or the app payment plan, the web config name, in this case, the staging slot name, the web config for my staging slot. There's also all of this stuff that you probably don't want to keep in here. You probably don't want to deploy the record of all of your previous deployments. So when you use this template, you probably just go and get rid of all of this sort of stuff. You can build these from scratch as well, but I find this is an awesome way of getting started with it, to see this is generally what I need to deploy what I have now. And then there's bindings and things like that. Now, I've gone ahead and I've added these two things. So I have my ARM template. I deleted the deployment parts of it because I don't need those deployment records. And I've basically set this up to be deploying to a new website called ASP.NET Full-Demo. And that website and that resource group does not exist right now. So this is the template and their default values. I also have parameters. Now this is one way of doing it. I wouldn't necessarily recommend this way of doing it, having the parameters for an environment in source control, because you tend to have things in here like access keys and stuff that you probably don't want in source control, secure stuff like that. But just for the ease of getting through this stuff, I've just put these values in there. So now basically I'm saying, here are the resources that I have that I want to deploy. I want to deploy this to ASP.NET Full-Demo Azure websites. I have a staging slot that I want to do. I want a S1 server farm. And then I can tell it what resource group to deploy to as well. So this is in my source control. The way I would add this to my release definition is I could go and edit. You may want to do this as a pre-environment. So before dev, actually run a step to provision all the stuff. I'm just going to do it in this dev environment. You might also want to do it in a separate phase, but I'm just going to add it to this first phase that I've got. So let's look for resource group, and you can see Azure Resource Group Deployment. So let's add that step. And then all I'd need to do is add the Azure subscription that I'm deploying to, the resource group itself, and this does not need to exist. I could give it a name for something that doesn't exist yet, or I could use a variable that changes depending on when I'm deploying or something along those lines as well. And then a location, and then I can say the template lives in this particular location. Now, because we're only getting artifacts from the build, I would also need to change my build definition to say copy those 2 JSON files into that drop folder so that I could use them subsequently. I could run through all of this and do all of this, but I'm conscious of time and airplanes and things, so I'm going to just say this is the way you would do it. You would point at a particular file for the template, and then you would point at a different file for the parameters. But, yes?
I was saying, those, I think you're probably getting to it next.
Mm-hmm.
So make those template things dynamic.
Yes. So the downside of this is that file, so the question was, can I make those template parameters dynamic? The downside of having this file is that this file lives in source control. If I need to change where I'm deploying to or something like that, then I'm changing my source code and then waiting for that to go all the way through. And if that's wrong, if I've made a typo or something like that, that's not great. The other thing is, if some of this information is sensitive, I probably don't want to put that in source control, right? So access keys and things like that. What you can do is this override template parameters section allows you to do things like, and I can't remember the exact format, it might tell me, it does. So I might do something like, admin username, and then give it a variable. What that will do is it'll override that parameter in the template parameters file when I do this deployment. That variable itself can live, for example, in these process variables or in the variable groups that I have. So I could say my variable, its value is, I don't know, something secret, spelt wrong. And I can also say that's secure now. So people can't actually read that back. That's one way of making that secure. And I can also scope that to different environments. So say that variable is different for my dev environment and my production environment. I could also, if I go to my library, let's let it leave. If I go to library, I can set up variable groups that pull from Azure Key Vault. So I could not have any of this stuff in VSTS at all. I could control that with my Azure AD groups, set up a new variable group and say, the secrets come from Azure Key Vault. And they will be exposed during my deployment as variables that can be used and that will overwrite those template parameters. But I can't get access to them here. As a developer or as a DevOps person, I can't see any of those secrets. They're not going to be made available to me. They're stored in a secure way in Azure, and only production sysadmins can get access to that, for example. So that's how you might do it dynamically. And that's usually the pretty common practice for doing this stuff. Cool. Let's leave that one. So what this allows me to do by adding that Azure Resource Group deployment, it allows me to, I've gone to the wrong place. It allows me to make sure that the infrastructure looks the way it's supposed to. So if we go to edit that definition again, and I lost that task, did I? Yep. So let's just grab that again. One of the things that I can set up here is the way that this behaves. The action is create or update resource group. Sorry, not the action, the deployment mode. So this is incremental at the moment. There's 3 options here. There's incremental, meaning if I've added something to this deployment, let's say I'm only caring about deploying the Azure web app. I might have my template which only has the Azure web app defined in it. And what that will do is if the Azure web app doesn't exist in that resource group, it'll add it. If it does exist but it's different, it'll modify it. If there's all these other resources in that resource group, it'll just ignore them. They're fine. It'll basically incrementally change whatever I've got in there. This is handy if you want to have different templates for all your different environments. So you want your dev environment to define your dev stuff, your production environment to define your production stuff. You can just define those things in those templates, and it will just incrementally add them as it goes through your environments. You could also say complete, which means get rid of anything which is not in my template and put the stuff that I've got in my template in there. So in other words, this is what my Azure resource group should look like. If there's anything that doesn't belong, get rid of it. If it does belong, it's in this template. That's a little bit dangerous sometimes because it'll tear stuff down.
Awesome.
It's pretty awesome. The other one you can do is validation only and just say, look, all I'm doing is checking that this Azure resource group matches what I'm saying it should look like. And if it doesn't, fail this deployment and tell me about it. So you can do that as well. Yeah.
So just to extend on that, as an IT admin, I look at that and go, well, I can go and do an extract of your whole Azure subscription as a big JSON object, and then check. So basically check the code out every night as a JSON object for the description of your Azure subscription.
Yep.
And then check it into code control and do a review the next day and see if it matches.
Yeah, absolutely. So that is something you can do. So
and then throw alerts and all of that great stuff.
Yeah, absolutely. So as a sysadmin or operations person, you can have your own release definition which only cares about templates that you have defined.
Yeah.
So the developers can have their own build that doesn't care about the infrastructure at all, or their own release definition that doesn't care about the infrastructure at all, and you have a separate one which cares about the infrastructure, and you can update that as required. Having them separate has pros and cons, obviously. Like if you change the web app name and the developers haven't changed that, the whole thing explodes. But yeah, you can have a lot more control over that as well, which is quite cool. So this is a good way of making sure that all those resources are there as well. The last thing I just wanted to talk about really quickly, how long have we got? Oh, I should be in a cab, or Adam should be driving, is monitoring. So because this is just a brand new website, there's no point looking at application insights for this. So let's go to this smart hotel website. If you've watched any of the Connect videos from last year, you might have seen this website. It's basically Smart Hotel 360. It's a site where you can bring your pets along to the hotel. Now I know there's a tiny little problem with this, so I'm going to just do this twice. Basically, it lets you upload an image, uses Azure Cognitive Services to look at that image and identify what animal it is, and then tell you whether you can bring that animal into the hotel or not. So I've uploaded a dog. I actually know that this is going to fail the first time, just because I haven't spun it up yet. So let's do that again. I'm going to grab a dog. I'm going to say OK. It's going to upload my dog image. Cognitive Services is going to look at it, say this is a dog. We're OK with dogs being in our hotel. While that's working, oh, there we go. Your pet looks like a dog looking at the camera and it's accepted. I am now going to upload a picture of a cat. It's going to upload the image, analyze it, say this is a cat. That is not an allowed pet. So I'm sorry, you can't put this in. As a user, maybe this is a bug, or as somebody who's testing this is some behavior that I don't want. So what I'm going to do is I'm going to open up Application Insights for this Smart Hotel website. So Application Insights is gathering information about all the requests that are made to Azure, all of the resources that are hit as a result, and how all of that behaves together. It's going to track usage, it's going to track availability, it's going to track all of this sort of stuff. So you can see our average server response time is about 1 second. With page load time, here are server requests. We've got a ton of information in here. This is just the overview. You can set up alerts to say, performance is degraded, send me an email, or performance is degraded, give me a task to actually fix that. So I'm going to follow this one, which is that there's a bug in here where cats should be allowed in the hotel, right? So let's look at our server request and try and find that request that was made. Now I can see that this was made, is it server requests? Maybe it's failed requests. Dependency calls. Oh no, here we go. So this is a request to get home index Let's just follow that one in and pretend that was the URL that we hit. We can see that all of these requests happened. Here's a 200 that occurred. Let's actually go back one. I want to get the right request. So let's refresh this. Is there a failed request? Nope. Oh, let's drill into this one. So this is a GET request. You should be able to see in here we can drill into that actual request, which took 200 milliseconds. So that was probably the second one that I hit, the second time that I saw that page. And this GET request to the server happened at this time. It came from Kirribilli, apparently, which is close, pretty close. It was against our production environment. There were no calls to the remote dependencies. If I drilled into the API call, we would have seen the calls to remote dependencies where it hit Cosmos DB databases. So we can trace that all the way back. This is why I kind of wanted that one. I'm going to try one more time to get this actual request. All right, let's refresh this. Oops, not this one. Come on. Nope. See if we can get some in server requests, in failures. No, all right. People are working on this all the time, which kind of makes it annoying because I can't 100% rely on this working. All right. Anyway, so we drill into basically the request that we saw, and then at some point when we get that request, we can say, all right, this is the thing that we need. This is the information we need to reproduce that actual request. So let's say it's this one here. Now I want to send this back to the developers to say this needs to change, right? So I can click New Work Item. Now this has already been set up to connect back to VSTS, which is pretty easy. You just configure this the first time. So when you hit that work item, it asks for all the information and lets you configure it. We're going to say cats should be allowed, and then a smiley face thing. We can see all of the details that are there, and I can assign that automatically to me, for example. We'll zoom in so you can see it. So we're creating a new work item in this area, assigning it to me, and it's containing all the information about that actual request. So let's say OK, and then hopefully, as long as I haven't changed stuff too much, that got created. So if I go to the VSTS instance for Smart Hotel, which is here, this is my dashboard in VSTS. And in this dashboard, you can see all of the tasks that are assigned to me. Now before, I probably should have gone here first, but assigned to me previously, it had my previous instance of doing this demo, but you can see the one I did with the kind of smiley face there. So this task has been fed back into my planning, and I can get that information there. So as a developer, if I want to reproduce this problem, I have all of these repro steps that came from Application Insights. But even more than that, I have this link directly to the Azure portal, which is a deep link back to that actual request where the work item was created in the first place. So this is incredibly good for reproducing this problem, and it means that the stuff that's happening in production can get fed back. So this was like one example of creating a work item from stuff that I saw in Application Insights. You can also do it automatically on alerts. So if performance degrades by a certain amount, create a work item. If if you get any Azure alert that you've set up to do with availability of stuff, performance of stuff, number of hits in a particular URL, a funnel that's not working as well as you want or has degraded after the last release, create work items. And that will feed back into this kind of loop back into the work that you're doing. So, I didn't say that one properly. So approvals, back to these challenges that we had. Approvals, we have branch policies, pre and post deployment approvals, and deployment gates. Downtime we can work out with deployment slots. Infrastructure we can work out with ARM templates, and monitoring with Application Insights, which will let us feed back into VSTS as well. So those kind of challenges, there's a few ways that you can meet those real world challenges. We saw how that kind of, what's that, sorry?
I'm going to interrupt.
Yeah.
How many people are working on this feature set?
How many people are working on these features, do you say, or VSTS in general? So the question is, how many people are working on VSTS in general? I know there's about 40 feature teams. Does that sound right? Do you know how many people, how many engineers? A few hundred?
800 people working for Chrome were.
So about 800 probably engineers. Yeah, so they manage, by the way, VSTS is planned, built, and deployed using VSTS. And the first place it gets deployed is to the instance that is doing the deployment. So it's like changing the airplane engine while the airplane's flying, right? So with 800 engineers, with tens of pull requests every day, each one of those running 70,000 unit tests on a continuous basis, and 40 feature teams, feature flags that get enabled and disabled, all that sort of stuff. So the scale that they're doing this stuff is really, really high. And they're making sure that they're using the vast majority of these things.
800 is a pretty big commitment.
800 people, yeah. Pretty. It started with how many? 3, 4?
Yeah,
3 people.
Their technical debt is the feature flags.
Yeah. The comment was that their technical debt is the feature flags. They have a ton of feature flags, right? And they rolled their own feature flag system because there weren't really any offerings out when they did it to start off with. So they control their feature flags with PowerShell scripts, as far as I'm aware. Yeah, so once you start building up a lot of feature flags, which is basically an if statement to say, is this feature enabled for this person based on who they are, what server they're on, what group they are, what we've tagged them with. You know, if the flag is on, go down this code path. If the flag is off, go down this code path. Once you start wrapping too much stuff in those, then it's difficult to manage all of those flags. That's a challenge in itself. And it's a talk in itself as well, I think. Yeah. All right, I'm going to wrap this up because we saw this as well. So CI/CD pipeline with VSTS, but more than that, it's CI/CD pipeline with VSTS with all of these things we talked about. It's kind of your ideal way of starting to get going with this stuff. And that is all I had. Thanks.